So, if we're going to go and put together a concept map, right, so everyone knows about doing mind maps, and this is kind of like the next stage on. So, if we're thinking about electrolysis, right, if you're just doing a mind map, you do something about simple electrolysis, right, then we've got the electrolysis of brine, right, remember brine's salt water. You've got the electrolysis of aluminium, and we've got electroplating, right? So we've gone, so if this was a mind map, when you go and plate one metal with another, right? So if this is mind map, then that'd be it, right? There you go, electrolysis, they're the things that you need to know, right? Wonderful, right? When we're doing concept mapping, you go and you start putting together diagrams and you're explaining physical concepts as you do it. The idea is to go and it makes things a lot more visible, right? So it makes things, ooh. So if you're looking at simple electrolysis, right? This is where you're going to go and you're going to get like all of your key bits and bobs down, right? If you were doing it properly, you'd have more time than me and such forth, and you'd make it neater. Right, first thing, if it's electrolysis, you're always going to have a positive electrode and a negative electrode. You're going to join them together with a cell. Right, make sure that as you do it, you go use different colours. Right, just go and put the key point as you're going along. Right, so you need to do something. Right, electrodes. Right, about the fact that you're going and making a circuit. Right, this. Right, so if we were talking about the electrolysis of lead bromide, right, you need to talk about the fact that your lead bromide needs to be molten. Right, and it needs to be molten so that the ions can move. So do you see how we're building it up? Right, we're talking about lead bromide then. So we'll put Pb 2 plus, Br minus. You can go and then draw where your ions are going to move. So the lead. Right, what do opposites do? Opposites?
Attract.
Right, thank you. Right, so you can go and draw the fact that your lead is moving to the negative. You can draw the fact that your bromine is going to go and move to the positive. Right? Underneath, right, you can go and you can do the half equations. So Pb2 plus, that's adding, right, 2 electrons. Because if you think about it, if you've got something that's 2, what do we need to take away from 2 to get it down to 0? Well, 2, right? So that's got to be your half equation for it. That's got to be the amount of electrons that you add. Right, same with bromine. Right, we've got 2 bromines. So if we've got 2 bromines, we've got 2 electrons we need to get rid of. So it's Br minus 2 electrons. Right, so that's all of your half equations for it. But you've gone and you put it all around this section here. Right? And from that, right, electrodes. You could go, right, so if you'd spend more time than I'm going to do, and you'd talk about positive and negative. You'd talk about the fact that one's going to be the cathode, one's going to be the anode. You'd talk about the fact that the bromine, so anything that goes to a positive electrode, is going to lose an electron to it. Anything that goes to a negative electrode is going to pull the electrons off of it. Right? then you'd think, right, so electrolysis of brine is the next kind of thing if we were going to do a mind map. So you'd go through, same again, right, so brine, well, all brine is in salt water. So you might want to remind yourself that it's salt water. Right, if it's salt water, so we've got H2O and NaCl, right, because it's sodium chloride. Right, then after that, because when you go and pass a current through it, it breaks down into ions, you might think, all right, I'll work out what ions it's going to make. So that's going to make an Na plus and a Cl minus, a H plus and an OH minus. Right, so just by thinking about that and thinking your way through, you've already worked out your 4 ions that you're going to have in solution. Right, then we can go Alright, so same again. We've already talked about electrodes, so one's going to be positive, one's going to be negative. We don't need to talk about what's happening in the positive, what's happening in the negative in terms of it gaining or losing electrons, because we've already done that on that part. So we know that we've got OH minus, H plus, Na plus, OH minus. So the H plus is going to go and move towards that. Cl minus even. Right, and your Cl will go and move towards that, and you'll be left with NaOH in solution. Right, you might want to go think about this in terms of a 6-mark question. Right, so you do 1, 2, 3, 4, 5. Think about the 6 steps. Right, same when you go and you're doing aluminium. Right, so you go. Aluminium is slightly different because your negative electrode is kind of the container. Your positive electrodes go down into it. Right? When you're talking about aluminium, right? Think about. So you might do something on what electrodes are made of. So it's the fact that they're made out of carbon. If they're made out of carbon, what problems does that cause? Right, so we go in and we keep increasing the amount. Then we're adding more and more detail to it. Right, so the problems it's going to cause is the fact that carbon goes and burns away with the oxygen from the aluminium oxide. Right, and things like that. So we go and we gradually build it up until you end up, right, so this is slightly different from how I've laid it out, but the general principle is the same. So we've gone and we've built it up. So in this concept map, I've done the main points of making the copper sulfate. Right, then we've got the electrolysis of copper sulfate. Right, we've got all the 6 things you'll need for a 6-mark question on that. Right, in an exam, they're not going to ask you any more than that because that's it. Same with the electrolysis of lead chloride. It's just another example, but the same principle, right? Lead chloride, lead bromide, right, are 2 things that come up. Then your electrolysis of brine and your electrolysis of aluminium, right? So we just go and you just build it up, section by section. Then once you've got this, you can go back, highlight key points. When you've got an exam question in front of you, you can go back, make reference to this, right? If you've got an exam question, you might want to go, if you've got like a small book of exam questions or whatever, number them, whatever, you might want to say, right, so that piece of information goes with question number 5. That piece of information goes with question number 12, or whatever, right? It's kind of up to you how you go and use it. We keep talking about making flashcards. This, after you've done this concept map, and we remember you're using it just to focus your thoughts, to get all of your thoughts out of your head onto paper, for you to go away and think about, right, what do you need to go and add in, maybe look some stuff up. So after you've gone in, you've done this, then you can use this to help you put together your flashcards. If you've got exam questions in front of you, to do that. If you go in and you've got somebody else that you can work with, you can go and split the information up and explain it back to each other. And there's all sorts that you can do with it. Right? But that is the general principle of making one of these concept maps. So the same applies if you're doing one on digestion. You'd start off the way that I always think about it. Start off with what happens in math and take it all the way down to the end, right? And in between at each stage, just go and describe what's happening at each stage. Just chuck in some more information. So we've gone and we've put in about active transport and about villi and about gastric pits in the stomach. About peristalsis and such forth. If you're reasonable at art and you can draw these things, it's actually very, very therapeutic, right? Same with when we go and we look at the whole thing about going from fractional distillation all the way through to polymerization. So you've got your 3 diagrams, right? You can look up these 3 diagrams on the internet, they're all over the place. Just number the information. So you're thinking about things logically, right? And last but not right, this one, if you do one on bonding, and you get one on bonding done really early, and all the stuff on bonding is clear in your head, then that really helps with a lot of your stuff on your chemistry paper, right?